Hello, this is an update video on my project where I continue to develop a robotic arm with Arduino integration. Since the last video, I have made new modifications to the overall design of the robot parts to better suit functional parameters, 3D printed more components for assembly, and began designing the electrical layout for the arm to make it all work. One of the major design changes made to the robot arm assembly was modifying the joint enclosures. Originally, the base plate had two axle enclosures for holding the first joint, while the second joint had to enclose points on both sides on the other end of the first joint. These were removed in favor of one joint enclosure on both ends of the first joint to allow for ease of assembly later on, and reducing weight and making it more versatile for movement. Another design change made was on the first joint, where as a result of removing the axle enclosure on one side of the joint, the space made available was replaced with a defined semi-sphere joint endpoint. This made for smooth movement between each joint endpoints without obstruction. Another major change made was to the claw attachment assembly. An extra degree of movement was added to the claw assembly, allowing for a change in the pitch angle of the claw rest, along with the roll and claw grip servo motors, facilitating other degrees of movement. Additional components have been printed, including the base plate, holding and rotating the robot arm joints, and the two major joints of the assembly. The next major hurdle in the design of the robot arm was incorporating the electrical components into the assembly, such as the mini servo motors and the Arduino Nano. The goal is to be able to control the servo motors remotely with the use of a radio module to allow for seamless control of the robot arm movement. As I had done before, I connected a radio module to the servo motors that would be attached to the robot arm assembly, along with the Arduino Nano, which would receive transmitted data from the receiver radio module. Another radio module is connected to the Arduino Nano and a rotary encoder from transmitting inputs from the rotary encoder. When attempting to test the communication capability between both modules, I'd routinely run into problems such as data not being transmitted or received. Doing a little bit more testing and rewiring of the circuit, I made minimal progress in solving the issue. When analyzing the serial monitor for the receiver program, it was indicated that something was received through the radio channel configured for both modules. However, when attempting to display the data in the serial monitor, nothing would appear, or by default, zeros would be printed instead. After doing some more digging online on potential solutions, spanning over a couple days, I came to the conclusion that the radio modules may have become faulty due to incorrect wiring configurations that resulted in too much or too little power surging within it in a way that would cause damage. At this point, I decided to ditch using radio modules and instead use Bluetooth communication to wirelessly transmit instructions to the robot arm. To do this, I'll be using the AT09 Android iOS BLE Bluetooth module to communicate via an Android device such as my phone to the module attached to the robot arm assembly. It should make it a lot more convenient to interface compared to radio communication, where I'm limited to just the Arduino IDE serial monitor to interpret data being transmitted or received. I will post an update video where I'll provide any updates to the project, either for the 3D design or wireless communication setup. If you have any suggestions or questions, feel free to leave them in the comments below. And once again, if you enjoyed this video, leave a like. Thanks for watching.